Welcome, everybody. You will note that keynotes and talks are normally here to provide you with answers. I'm not in that. So this keynote's purpose is to present you with a question. You may have heard the catchphrase, "It's easier to ask forgiveness than permission." We'll explore that throughout the talk. I'm responsible for introducing it to the Python community many years ago, and we'll see exactly what it means. But it's important, sometimes it's more important to be aware of a question than have all the answers down pat. And exploring this question is what this talk is all about. And if when you leave, you know less than you do right now, that's good. Because you're putting your knowledge into doubt and thinking more deeply and acting with more self-awareness in this world, which is a good thing. So, first of all, some questions are false questions. Sometimes the question to should I look for permission or forgiveness is, the best answer is sometimes neither. And this is where I answer a criticism that's been leveled to me. In these presentations of mine, I use a proportionally spaced font with a certain deliberately fuzzy outline. I've been accused of using Comic Sans for that purpose and criticized for it. It's not Comic Sans. It's Apple's own chalkboard font. It goes with a old-fashioned background looking a bit like a blackboard. If you look at the font, this is chalkboard. This is Comic Sans. If you cannot tell the difference, I'm really sorry for you. If you can tell the difference and think that Apple's designers have no visual sense and this Apple thing, they should stick with fruit and don't know what industrial design is, well, take it up with Cupertino. I'm not going to get into that mess. So sometimes when you're doing something that you are convinced is right and have probed yourself and you know you're right, even if everybody else is pointing the fingers and losing their head and putting all the fault on you, standing your ground and saying, no, I am doing the right thing, I am not going to apologize for doing the right thing, is the right approach. That's one possibility. But let's go back to permission and forgiveness. The person who originally coined, or at least popularized that phrase, was Rear Admiral Grace Murray Hopper. All we know from her bio entry in the US Navy archives is that she had a PhD in mathematics from Yale, and her lifetime was from 1906 to 1992. That's a pretty shallow summary of a very long and incredibly fruitful life of an absolutely incredible person. So I spent some time digging into her biography and trying to understand what was it all about? What was she talking about? Who was Grace Murray Hopper? Nicknamed Amazing Grace, like in the very popular song, of course. Well, she was one of the main engineers on what could arguably be called the first electronic computer, the Mark I computer. She invented the concept of a compiler. She didn't use that term, but she invented the idea that you could write the instructions to the machine in a high-level English-like language, and a program could translate them into the machine for you. In the 1940s, that was incredibly revolutionary. Specifically, the language she developed to support this concept is still around. It's called COBOL. May not be the best language in the world. It's definitely a language designed by committee, so it has its warts and so on. But through that language and its predecessor, she definitely proved her point that you can program in a way that's much closer to your brain and have the computer take over the hack work of translating that into bits that are much closer to the machine. She was the first winner of the Computer Science Men of the Year award, literal, which shows you how exceptional she was, how much she stood out in a culture that just didn't see things like engineering as suitable for women. So they had named the award Men of the Year award, and they were at least humble enough to recognize that this woman was the best man in computer science in '69. She was also the first American citizen and the first ever woman to be nominated, to be awarded the title of Distinguished Fellow in the British Computer Society. Normally, up to then, it was all British citizens and all men. She was the first American and the first woman. She won the highest honors you could win for serving in peacetime, the Defense Distinguished Service Medal and the National Medal of Technology. The pictures down here show a few of her contributions and awards and things that were bestowed on her. Here, she's holding up a nanosecond. It's easy to think in terms, you're designing hardware or using hardware at a very low level, think in nanoseconds. She figured out that a nanosecond is about the time it takes at the speed of light to go 1 foot. And she recovered a roll of copper wire from a machine that was being decommissioned that rolls up to about 1 foot. But if you follow all the curve, all the roll, it's about 1,000 times that. So this represented both a nanosecond, the length, the diameter of the circle, and a microsecond, the whole circumference of this circles over and over. And that's what she used in the 60s when the concept of a powerful computer was bigger, 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 to explain computers of the future will be tiny, because that's the only way we can make them really fast. Because 1 nanosecond in the future will be a substantial delay. This is already true today. We have clocks in the many gigahertz. And this is the biggest a computer can possibly be and still respond within 1 nanosecond, because that's the time light takes to travel it. She also claimed to have identified the first bug, like actually captured it. It was a moth. She taped it to the laboratory diaries during the Mark I. That moth had entered physically into the computer and short-circuited a relay, making it work badly. And so it was the first computer bug actually caught. There's a ship named after her, which is a signal honor in the American Navy. And you can see USS Hopper, Hopper being her surname. What did she mean when she went on record at saying it's easier to ask forgiveness than permission? Remember, her career was mostly in the Navy. A very well organized but highly bureaucratic organization with rigid structures of command and control. It has to be, it's so large. It's not just about government or just about the military. A large private organization with hundreds of thousands of people is also going to be bureaucratic, or it just couldn't work. So what she's talking about is, how do I innovate while operating within a bureaucratic organization? Whether a government one, as in her experience, or a private one. Private firms inevitably are run, well, you can claim the CEO is the one running the organization, but the real engine keeping it together is middle managers. A middle manager is a highly trained individual who knows to perfection how to listen to your bright, new, disruptive ideas, nod sagely and say no. That's the middle manager's job. Because he needs to keep things on an even keel. Whether he's a colonel in the army, a rear admiral in the navy, or senior engineer in a private organization, that's his job or her job. So consider that she realized that. Pretty obvious that the bureaucracy's role is to keep things on an even keel, and so therefore it's antithetic to complete innovation. Complete innovation means destroying something that's working to get something that works even better. Obviously, it worked for her. Worked for her, given that she actually managed to deliver world-shaking, totally disruptive innovations, got promoted all the way to Commodore. The Rear Admiral title is actually just a renaming of the role that used to be called Commodore in the US Navy, and the recognition that was showered on her from both inside the Navy and outside it. So, how did she apply it? Well, I'm given a few already. This is an example. How did she get interested in engineering? Well, she really wanted to understand, when she was about 5 years old, how did her alarm clock work? So how did it know to wake her up at 7 a.m. or whatever? So she took it apart, examined all the springs and the gears and levers. Of course, she couldn't put it back together again. It was pretty amazing that as a kid she had managed to take it apart. And then went to her mom and asked for forgiveness. And she kept doing that to her alarm clocks. Apparently started to come out of her allowance. This is the title of her paper about automatic programming, which is what we would now call high-level programming, that is programming in a language somewhat close to structured English and having it translated into machine instruction for us. This is an example where asking for forgiveness worked. She had the intuition based on that nanosecond thing that powerful computer of the future would be smaller and smaller and smaller, and so single chip computers, which were not very powerful in were non-existent in the 60s and not very powerful in the 70s, focused more and more of her attention, and she was responsible for this CHIPS magazine, initially internally to the Navy, then it spread to other armed forces and then to the civilian realm. And she had originally called it Chips Ahoy, which is unfortunately a registered trademark, I think, of Nabisco brands. So obviously, it's not a commercially relevant misuse of a trademark. Nobody's going to buy the magazine thinking it's about the chocolate chip cookies. I don't know if they're for sale in your countries. They're still pretty popular in the United States. But the Navy lawyer nevertheless had a real bad time when they discovered the Navy was officially publishing a magazine with a trademark name without the permission of the trademark. They had her drop the Ahoy, so it was just chips. But the Ahoy, of course, is a naval reference that she had injected there. Nabisco Brands later was contacted, and of course they had absolutely no problem. They saw it as a funny way to honor their brand. They wouldn't obviously detract any sales, but still the magazine stayed named Chips. I don't think it's published anymore. It's probably an online edition by now. Why does it work to just do something and then, if you need to, ask for forgiveness instead of asking for permission before you do anything innovative, anything that matters? Bureaucrats, it's not about them as individuals. Some of them are great people, same for middle managers. But the incentives of a bureaucrat is to deny permission. As I said, a middle manager's real job is to listen carefully, make sure you believe that he understands exactly what your idea is, and then turn it down. Because the more brilliant, potentially revolutionary ideas get accepted, the more work it is for the bureaucrat or manager to keep an eye on all of them. And if something works out really badly, there may be a career risk for the bureaucrat or manager. Why did you authorize that project? It cost us millions of dollars and didn't do anything. Well, just say no, nothing happens. Nobody's going to blame you for, unless you're unlucky enough to get on record as saying no of something particularly successful, like the Western Union managers who turned down this crazy newfangled telephone idea. It will never work. Telegraph is obviously the best way to communicate, provides a permanent record. Who'd ever want to chat with somebody hundreds of miles away? That's how Graham Bell ended up as an entrepreneur. His preference would have been to have the Western Union, the telegraph company, with all of its resources, develop his telephone idea, but the bureaucrats' incentive was to say, no way. We'll just keep doing telegraph. They were unlucky enough that all the correspondence was recorded and it's now in the archives. But mostly, if somebody in the organization comes and proposes a revolutionary idea, you can just say no, and that your career risk is nil, as long as you're not particularly unlucky. Suppose you start anyway without actually asking the permission, and the project proceeds. Now you've changed the incentives of the bureaucrat or middle manager. The incentives are now to grant forgiveness because it is more work to go and discipline you for it. How did you dare spend $1 million on this project without permission and so on? First of all, if the project is a roaring success, well, the issue won't even come up. You won't even have to ask for forgiveness. But even if it does come up, presumably because something didn't go quite as well and smoothly as planned, the path of least resistance, least work, least complication is for the manager or bureaucrat to wag a finger at you and then let go. Of course, if the project is successful, even if some aspects come up as having been done against regulations, the incentives for the person are always going to work out in your favor. Does it have any application except innovating in a bureaucracy? I claim it does. Of course, we'll start out with the concept of permission and forgiveness in Python, which is the way I originally introduced the whole meme to the Python community. And then we'll explore completely and apparently unrelated issues, such as dealing with concurrency, with a specific example of source code control systems, networking system, general business strategy regarding innovative projects, and then, last but not least, we'll focus on when it doesn't work and when you should rather ask permission than just go ahead and then ask for forgiveness. So this is essentially a summary of the rest of the talk. This is the classic example. A natural impulse, especially for somebody coming from other languages to Python, is, okay, I'm supposed to read this file. Well, first of all, I'll check if the file exists and I have read permissions on it, in which case I will open it and read it. If the file doesn't exist or I'm forbidden to read it, I'll return some default value that was passed. This general approach to programming, where you check that all the preconditions are fulfilled and then and only then you operate, is so bad, it's become an official bad example on the online docspython.org site. Why is it bad? Because this is, for example, this is a multitasked world. The moment you check this, maybe the file did exist and was fine, and then another process deletes it just before you try to open it. So it was okay, you did have permission a nanosecond ago, that doesn't mean you have it now, and there is no way for you to say, stop the world. No other process is allowed to do anything. That's not how programming works. Other processes may always be doing stuff to you. So that's one example of why this is wrong. And this is the right approach, the Python approach. Just try to do it. Just try to open the file. If that doesn't work, the file doesn't exist, or it exists but you don't have permission to read it, or whatever, you will get an exception. That is, you will ask forgiveness by catching the exception. If the operation worked, then you will proceed. There are some technical differences in Unix-like systems. Access uses the real ID versus just doing it uses the effective ID. I don't think that's a big problem with any scripting language because it would only surface if you had a setuid script. And if you have a setuid script, you have serious other problems. Let's not get into the race conditions that come with setuid scripts. Just don't do them. So, it used to be that the better to ask forgiveness approach applied very strongly to type checking. You are supposed to do duck typing. Another idiom I'm credited, possibly wrongly, but Wikipedia credits me for introducing it to the Python community. That is, you don't check if X is an instance of a certain kind before you increment it. You just try incrementing it, and if it's the wrong type, then you take the alternative action. Why was this considered to be bad? Well, integers and floats are not the only things you can add 1 to. All kind of other types of numbers could be handled that way, and so this is unnecessarily restricting your operations. However, we now have abstract base classes. Numbers.number captures the concept of a number, any kind of number. So checking, asking for permission to increment it, meaning it's a number, then I can add 1, has become idiomatic and is very well defined for the few cases where the appropriate abstract class exists. I call it a type class, using a term taken from the Haskell language, because it's not really a type. You cannot instantiate a generic abstract number. It's abstract. It just says which types are numbers, which types are not. And it's really handy because if you write your own class that represents a number, like people did when they wrote the decimal class and so on, you can quite easily claim it is a number by either inheriting, if you want, or simply registering yourself with the abstract class, so that its instance will give you the right answer. So whenever you're faced with this kind of problem, take a brief look at the collections in numbers modules and see which abstract classes exist. If your problem matches one of the existing abstract classes, then just use that. Don't do the duck typing approach. You want to identify numbers, check for instances of numbers number. You want to identify sequences. There's a collection, mutable sequence, and so on. And beyond the standard ones, if your program is also accessing some framework, there might be other, like geometric figure, for example, or something in a framework about 2D graphics or geometry that you might also want to utilize. What if the issue is not really well covered by the existing type classes, abstract base classes? Should you just write your own? Sometimes, but be very careful. It's very, very easy to overdo it. You need to remember that beyond their effect into your code, these classes are meant to represent important concepts in your application area. So you just write one because it looks handy. Think about whether it represents something conceptually important, quite apart from the implementation. Is it capable of multiple implementations, at least theoretically? So people, for example, like with numbers, obviously the implementation of integers, the implementation of floats, the implementation of infinite precision integers, those of potentially infinite precision float and so on, are all going to be different, but they're all example of the concept of a number. Is this the case for whatever application-specific construct you're thinking of? The multiple implementations can provide very important advantages in memory, for example, versus performance, and so on. An integer, if it fits among various types of number, an integer is something that fits in a machine register in the end, and so can be manipulated much faster than an infinite precision, which could be a list or sequence of many machine words, and so on. So, if you have this, and you can reinforce it through sometimes some abstract method implemented in terms of other methods which the concrete model must apply. That's not mandatory, but numbers doesn't really have them, for example. But if you also have that, then that's a very good sign that you're on the right track in designing a new abstract base class. Just make sure the criteria, the conceptual criteria are met, because it's very, very easy to fall into the issue that to a man whose only tool is a hammer, most all problems look like nails, because essentially the only thing you can do with his hammer is beat on them. But actually, if the problem is a screw, you'd be much better off using a different tool, and that applies very strongly to abstract base classes. Yet another observation: instead of either asking for permission or forgiveness, sometimes going through a default intrinsic is going to work even better. I hardly ever do something like check if, use the hasAttr built-in to check if object X has an attribute foo. Rather, what I normally do is I try to get the attribute foo from object X, but if it doesn't exist, I provide a default value to use instead of the non-existent. Similarly, for accessing a dictionary, instead of checking if the key is in the dictionary, use the get verb, providing a default to use when the key is not a key in the dictionary. Instead of either permission or forgiveness, these kind of approaches let you specify an alternative plan. Do that, but if that is unfeasible, use this default. Now, moving out of Python-specific issues, here's another example where permission were so much better forgiveness were so much better than permission. Concurrency. The traditional approach, permission-based, is there are mutual exclusion constructs such as locks, and before you're allowed to do anything with this object that is being used in a concurrent way, you must acquire the lock, essentially temporary ownership of the thing, and then go ahead and work with it. What's the problem? Well, you might well be the only one interested at that particular time in this object. So you're taking the big context switching overhead of acquiring all the locks needed and then releasing them when you're done for no useful purpose. The modern approach, and it's steadily growing on us, is the forgiveness approach. Designate a set of operations as a transaction. Just do it. If this violates some concurrency because somebody else has changed the object while you were working with it inside your transaction, the system's job is to detect that and give you an error. An error that you can catch and retry. I believe the first important commercial example of this distinction was when Oracle launched their first SQL database. It was based on optimistic concurrency. While everybody else, like the pioneer in relational databases, IBM, and other new competitors, was busy figuring out ways to lock tables, lock records, lock range of records, and so on, Oracle focused on detecting during the commit that the transactions was tainted due to the concurrency issue and failing on you. As a result, it could easily be, depending on the workload on your database, 2 or 3 times as fast. Enough competitive advantage to make Oracle the #1 database firm in the world, starting from nothing versus giant IBM starting for everything. Remember, all the theory of relational databases was invented at IBM, despite which they hadn't considered the optimistic concurrency that Oracle was based on. These days, OCCs are everywhere. Optimistic concurrency constructs. Software transactional memory is an example. It's if you have the good luck of working in a system that supplies software transactional memory, you forget all about locking and unlocking and deadlocks and things and just fly along. Just perform transactions, check if they're tainted, and then redo them or retry them. One example that is may not be immediately obvious of optimistic concurrency is source code control. Those of you who are old enough, about my age, to have started with a traditional approach may recall when the way to do software development, source code control, software development with multiple people was, okay, so you want to change this file, you have to check it out of the repository, meaning you now own it temporarily, you're the only one who can work on it, nobody else can. And everybody else is blocked. Everybody else in the team is blocked. They cannot change that file until you put it back in with your changes. Nowadays, what you do is you do your changes and then commit, and if somebody else has also committed since you last synced, you get conflicts and you have to resolve them. Think about it. The traditional approach says, okay, I need to change foo.c. So I check it out, so I think, oh, the interface has changed a bit. I also need to change foo.h. Meanwhile, in a room at the other end of the world, somebody says, oh, I might change foo.h. They get it. Says, oh, I really need to tweak the implementation as well, so they also need to change foo.c. This is human deadlock. I'm holding foo.c and waiting until you release foo.h. You're holding foo.h and waiting until I release foo.c, so we're both blocked forever. It's kind of annoying if you're in the same room. If you happen to be at the opposite end of the world, it can really steal days of development of your flow. With conflicts needing to be resolved, don't know how often it happens to you, I don't know how big and distributed is the team you work on and so on, but you're never at least totally blocked. Networking approaches also had a similar development. Consider, for example, another IBM idea I have long past in IBM research and really admire a lot of what they've done. In the token ring was like, don't know if you've done that at a summer camp or something, everybody's sitting around a fire and there's this token, whoever holds the token can speak if they want, otherwise or when they're done, they pass the token on and you can't speak unless you're holding the torch or whatever you're using as a token. It's kind of a way to make sure everybody can participate, and it's much more ordered than just a normal approach where everybody speaks, interrupts somebody else, excuses himself, and so on. In networking, the token ring was based exactly on this concept. Point is that most of the time, most nodes have nothing to say. So they're just wasting cycles, taking the token, handing it on to the next node until it does a full circle. Modern networking is based on forgiveness. Instead of trying to prevent collisions of packets being put on the wire or whatever, the ether, whatever. At the same time, the main thing is being able to detect collision. Instead of collision avoidance, collision detection has essentially taken over all of our networking. I very much doubt any of you have any networking devices, are using them now or have them on your body that are collision avoidance. There's the all collision detection. You just start putting your packet on, start speaking, and if you detect somebody else was doing so at the same time, you back off. Ask for permission, for forgiveness, sorry, and try again a random interval later. It's usually much more robust. It can get overstressed. It can crash. If every node is trying to put signal on at the same time, it degrades exponentially, but that's a pretty rare occasion. Now, even taking a step back from strict technology, think about how do you, as a company, proceed to launch a new product on the market. The slow but safe approach. You put in focus groups, you have interminable meetings, find out exactly what the customers want, and do a top-down design based on commercial requirements, translating into technical requirements, integrating them back up, and then when you're all done, then you finally do a big launch. And, historically speaking, you find that 3 small firms with a more agile development are already out there gaining market share and mind share, and your big product is a total flop because it's so late. In the more forgiveness-like approach, you just launch a beta. It works better with software because you're not asking people to shell out money for a piece of hardware that they may have to throw away in 2 months, but it can work even there if it's a cheap enough hardware. So you just launch and iterate. You keep failing, but failing fast and coming on with a new idea that matches better the reality. You find out about what do people actually want much better by putting product in their hands, metaphorically, and seeing how they use it, if they use it, what are they complaining about. Of course it depends. I don't think it would work well for, say, an aircraft carrier. Launching new generations of aircraft carrier every few months would be kind of impractical. But especially for software development, the forgiveness approach can work much better in most fields of software development. So, is go for forgiveness instead for permission a universal panacea? No, it's not. You have to absolutely have to be aware of when it doesn't really work well and when you should adopt a more disciplined approach, more structured approach. The first big example is that when there are rules and principles in place that are appropriate and sensible, and a process designed to work with them. Far too many places have rules and principles and no real process on how you work along the process and rules. One of my main positive example for a structured approach is security. Security is one of those things you cannot really bolt on to a product after it's finished. Oh, it's finished except that everybody can see everybody else's data. Let me hack something so that you can only see your own data and not somebody else's. If it's done in an add-on splash, it ain't gonna work. Smart people will find out ways around your hastily superimposed security structure. So it's perfectly reasonable, perfectly sensible, perfectly appropriate for a firm to say, before any multi-tenancy product holding data from different customers, for example, that must not be allowed to see with or tamper with each other, before work is allowed to proceed in it, a panel of security experts must review the architecture. They will challenge the developer. They are bright people. You know, it takes a thief to catch a thief. The best security experts are those who could be the most dangerous hackers if they weren't working in the white hat realm. They will propose, oh, what if I did this and this? And often you find yourself, oh, then you'd have access to everybody's data, because they're smart. And so you go back to the drawing board and, with their help, design something that puts security where it belongs, at the heart of the product. Security cannot be an afterthought. It, to some kind of character, especially young people, having to work within the system may seem limiting, but when it's sensible, and security I think is a great example of when it is, it works so much better than trying to retrofit. I'm all in favor of incremental development for most things, but it's important to identify the few cases in which it cannot really work, and security is one of them. I'm sure we could find other examples. The other case, and it's much broader and less well defined, is about human interactions as opposed to developing products and things. My favorite reference for it is also one of my favorite philosophers. It's Kant in the Foundations of the Metaphysics of Morals. He tries to lay down a principle. It's not about permission or forgiveness, it's about what is the right thing. Act in such a way that you treat humanity, whether in yourself or in others, always at the same time as an end in itself and never just as a means to an end. Humans, including yourself, are not tools. They're not little bits and pieces in a machine. You have to be always aware humans are humans. Humans are ends in themselves. So, if what you're doing is treating people like your tools to your ends, then that's just wrong. And you should think of a permission approach. One example, it is not okay to say, I need to graduate, but working on my doctoral thesis is just too much work. Hey, I've spotted this doctoral thesis from a little obscure university over there nobody's ever heard of. I'll just copy that or generously fish in that pool and get away with it because nobody else will know it. In this case, you're using another person indirectly, the guy who wrote that other thesis as simply a means to your end, which is avoiding work and getting your undeserved doctorate degree. That's just wrong. If you are doing research and find some obscure thesis that brings points important to your research, the only honorable approach is to go and ask the person to quote with full attribution from their work into yours and make sure you are adding something original, otherwise you're not deserving of the doctorate. So that's one example, but I'm sure you can think of a million others. Stealing credit more generally, I'm talking specifically about graduate students stealing credit, but that happens at work all the time, you know, or could happen if you just erroneously applied the ask for forgiveness. Oh, I'll just steal the work John did because it's pretty good work, and if I get caught out, I'll just apologize. No, that's not what forgiveness and permission means. If you want to elaborate on John's work, you ask him, you make it clear and plain and honest, and it works. Okay, this is the URL where you can find the PDF. I think we have time for a question or two, not just questions, observations, anecdotes, dissent. Yes?
One observation when you were talking about the optimistic concurrency and things like that, it reminds me of Gmail. On my computer will try to refresh. If it can't, it then waits for a few seconds and tries again and just keeps trying and adding time to how long before it tries again. But it first just assumes that it can do it.
So just repeating to make sure it gets to the record, one example of somewhat optimistic, not exactly concurrency, but something like that, is an online program like a Gmail that just, it doesn't really know at any given time whether it has internet connection or not. You're going around with your laptop and you get from times where you have it, times where you don't. It just tries refreshing, and if it can't connect, it lets you know and keeps trying, not like more and more rarely, because if you're out of internet connectivity for 5 minutes, it doesn't need to keep trying every few seconds. So we'll try after 10 minutes or something like that. That's the same back off that for example, the collision detection systems do in lower level networking. So that's one example. Anybody else? Well then, thank you very much.